Good morning, good afternoon, and good evening. Welcome back to another show of From the Field. I'm your host, Casey. I am based in Wellington, New Zealand. And yes, you've probably noticed that I am sporting the old chopper stash. It was in support of Movember, which, as well, if you probably noticed, is also over. I made a deal with one of the team members that if they hit their goal for the month, then I would turn up to one of our company events looking like a with the dirty mo. So here I am, and now I have to actually also go live with it. So I'm getting so a lot more people getting to see it, which is exciting. With me, I have Sam with me. What looks like to have video issues. There he is, the man, the myth, the legend. So Sam is going to be talking to us about 5G. And why don't you introduce yourself, Sam?
Sure, Cassie. First of all, your mole looks great, man. It looks great on there, and that's for the great cause. So that's great. I had the opportunity to do it a few years ago, actually. So you can imagine how it might look like. Yeah. Good afternoon. Good morning, everyone, and thank you for the intro, Cassie. It's an absolute honor and a pleasure to be on your show. Thanks for inviting me. Really appreciate that. My name is Sam Kamanuri. I am a senior solutions architect at Amazon Web Services. What I do is I work with enterprise customers in New Zealand, or large enterprises, to understand their business and technology goals and strategies, and then help how AWS technologies be an enabler for those goals and strategies. So yeah, thank you for featuring this topic of 5G, Casey. I'm really glad to join you to bring it to our audience and share from my experiences.
So good, and you can keep it a little bit less formal. Don't need to sound like a robot. And fast and loose, that's how we like to play it. And also, I think a lot of the things we're going to be talking about 5G, we're going to be talking about wireless technologies in general as well, because there is a multitude of them out there. 5G being the new flavor of the month, obviously. But you got LoRaWAN, you got 2Gs and 3Gs and 4Gs and all of the Gs out there, to be honest. And it's just about applying the right one for the right use case. But a lot of people have already dived deep into those technologies. If you have any questions on those particular technologies, do feel free to chuck them into the comments, and we can get to them as well. But yeah. So Sam, do you want to jump into it, or do you have anything else that you want to actually have a quick chat about?
Yeah, absolutely. We could cover various topics as we go through, Casey, in terms of LoRaWAN, 5G, and so forth. Also, I'm cognizant that covering 5G technologies in 1 hour span can be quite ambitious. So, nevertheless, we're keen on offering our audience some insights into the market trends, technology overview, as you have rightly pointed, and AWS vision, unlocking the potential of 5G, some use cases we can talk about, and some real world scenarios, and how the time permits. So that's a kind of the broader plan or thinking. So yeah, why not? We can straight jump into it.
Sweet, there you go.
Excellent. Thank you very much for bringing that up. So as you know, Cassie, and our audience as well, that mobile networks have been around for 40 years. It has a 40 years history and have undergone significant changes in terms of the frequency, bandwidth, technology, modulations, and access techniques, and so on, right? So the first generation, maybe if I can just set the context a little bit here, the first generation of mobile networks was deployed in Japan, or Tokyo to be precise, in 1979. And in 1980s, it gained popularity in many other regions as well, like Europe, America, and so forth. So since then, there have been various generations of the technologies. So if you look at here, right, the first generation of mobile network was mainly focusing on voice. In other words, the support was limited to voice. And then we had second generation supporting text, or SMS as we call it, and the third generation, or we call it 3G, defining the transition to broadband access. I think that was a significant evolution, right?
I remember.
Yeah.
Yeah, I remember paying 20 cents, or was it 25 cents a text message back when I was younger, like early college, more than 2 decades ago. Yeah, and it cost an absolute fortune. So and now I believe everything's like always unlimited SMS nowadays. So like definitely progressed.
Absolutely. I remember, spending a lot actually on text, and even in countries like Singapore and India and the US as well. So yeah, it was mainly the technology was evolving. The cost of the operations was quite high. And then with the 3G, right, the data rates, we started supporting the data rates and measured in hundreds of kilobits per second. When was the last time you heard about kilobits, Casey?
Well, I had 56K internet back in the day.
Yeah, sure. Yeah.
So I was living the dream long ago. I remember when YouTube first came out and actually trying to do that on 56K internet. So
Yeah.
it's been a while. I will definitely admit kilobits is not something that is oftenly banded around, except for on the low bandwidth solutions.
Sure, absolutely. Yeah, but that's how the journey started, right? So yeah, then we had the 4G system. It was an enhanced version of 3G networks, or we call it LTE. That is a long-term evolution, and LTE advanced wireless technology that was used in fourth generation. So there was a significant improvement, right, in terms of the technology that started offering HD video started supporting HD video streaming, much higher data rates, up to 1 gigabits per second. That's it was a massive improvement, isn't it? And then we had a 5G network using advanced technologies to deliver ultra fast. That's the key, and it's ultra fast internet and multimedia experience for customers, right? So bringing a new experiences to the customers. So if I categorize, the 1G to 4G as the technology that's interconnecting people, and control. If you look at the 5G, that is, it's interconnecting people, but it's interconnecting devices as well. Well, that's how I would like to categorize before setting the context for 5G. Sorry.
Just to also jump in there, it's quite interesting because in the agri-tech world, where we generally are dealing with rural farmers and places that are in ditches and everything like that, we quite often see that the solutions gravitate towards 3G because it still has a moderate amount of bandwidth, but it has by far the best coverage in the country. And I think even in Australia, that holds true as well. So it's quite interesting to see that you will see that 3G is doing a lot of that interconnecting of devices as well, doing it in the IoT space.
Yeah, absolutely. Casey. Also, if you look at interconnecting devices, it's about controlling the machines, controlling objects, right? It's a platform for innovation that can enable new services, that can empower new user experience. That's the key, isn't it? Not only from the end customer point of view, from the businesses as well. It's creating a platform for boundless, I would say, right? The innovations and connecting new industries, right?
Yep.
The industry today is still, sorry, go on.
Yeah, and I was also going to say that a lot of people would also have heard LoRaWAN, which is a new flavor of the month
Mhm.
when talking about device connectivity. Where do you think that
Mhm.
sits within this space, or is it kind of like
Mhm.
its own unique technology aiming to solve its own like problem space?
Mhm. Yeah, it's interesting you mentioned that. It might not be an apple-to-apple comparison in my viewpoint. LoRaWAN is it's a relatively simple technology built from the ground up to serve specific use cases, isn't it? So it does entail, lower costs, greater accessibility, and enhanced battery performance. Nevertheless, in my view, LoRaWAN based connectivity can be seen as a 5G. Well, it cannot be seen as a 5G replacement, right? So they can be complementary. Yeah.
Mm. Yeah, I see them as serving two different distinct use cases, where LoRaWAN is aiming for that long range, low bandwidth, and 5G is
Yeah.
aiming for that, short range, high bandwidth use cases. And 5G is much more of your common standard that is been used in telecommunications, and LoRaWAN is more of that hobbyist IoT domain where you have, as you mentioned, that's very specific requirements for having that long range from base and being able to
Mhm.
give that like simple instructions over like that low bandwidth. So I think a lot of drones and a lot of like smart gates, for example, would be using it in the future.
Yeah, precisely, Casey. So if you can go back to the 5G, the evolution, right? Please bear with me. Sometimes the
Yeah,
sensors in
these
my
rooms.
room, yeah, the sensors in my room, they do not recognize me as a human. So, so please excuse me. But you're doing pretty great. Your lights are not turning off. So,
I actually have a secret. I have someone else in the room that is dancing around for me at
oh,
5 minute intervals. So I just offloaded the problem.
you should have shared that secret with me. So, so I have to dance myself and talk.
Yeah,
That's fine, as long as you're okay with my dancing.
it's all good.
Uh,
Interpretive dance is even better because that gives you more room to.
that's right. Yeah. So,
I won't
yeah.
dance. I'm terrible at it.
Yeah. In terms of the 5G evolution, right? This is a if you could observe, each generation of the mobile network is a decade long endeavor. So there's a lot goes into that in terms of the technology and in terms of the transition. Sometimes you could see minimum 20 years of life cycle, right? Um, Maybe we can draw some parallels with the LoRaWAN as we go if time permits. But maybe you can briefly touch on some of those key pain points or the key features as well of each of these mobile technologies. Like for example, if you start with 1G at a high level, the mode of service was voice only, and the access technique was FDMA. If I'm going into the using a technical terminology here, and the frequency was very low, as you can imagine that. So one of the key challenges with that was a poor voice quality due to interference, right? And the battery life was poor and limited number of users because that was the first generation, as you would expect, and the cell coverage was very limited as well, and roaming was not possible when well I could recall using it in 90s, but by the time I think roaming was already possible. But the first generation, I didn't have the chance to use be a customer of the first generation. Yeah,
I was less than 10 in the 90s, so I wouldn't be much help.
sure. I'm showing my age here, but yeah, I'm definitely not done in my 90s. So, yeah. I used COBOL for programming, so that shows my age. The 2G when it comes to right, the some of the key features that added was SMS as you briefly touched on earlier, and the roaming was possible as well with 2G, and the first internet at low data rate, mm, it it was supported, but still, it was low data rate, limited mobility, and the features was very less, and so forth. With 3G, I think there was a significant uplift, and the data rates, relatively higher. The video calling, I would call that out actually. With the 3G, the video calling was made possible. It was supported there, and mobile apps support was there with 2G, and multimedia messaging support, TV streaming, and so forth, right? So even 3D games were supported in with 3D. I myself never played 3D games, but back then, so.
I think also 3G coincided with the emerging smartphone and tablet market. It's a smart tablet, I think, what preceded the smartphone boom. So I think that's where also what really helped 3G take off, because you started having that greater screen real estate. And I think the Blackberries were definitely around at that point.
Absolutely, BlackBerry and Nokia, if I could recall, and Ericsson, they were leading the market at the time. Again, the infrastructure were very expensive. The equipment and implementation was very expensive. The spectrum licenses were very expensive. The bandwidth requirements were very high to support the higher data rates. So they had some challenges as well. So challenges and gaps. And then with 4G, you got a much higher data rates, right, up to 1 Gbps. And security has always been enhancing. I'm not highlighting it, but with every technology, there's an improvement in terms of the security. And with 4G, there's a reduced latency. So the organizations or enterprises, or even small scale as well, they start using for mission critical applications and HD video streaming with 4G. However,
yeah, we also got this couple people in chat. So TAOVG mentioned that 3G was definitely for sure like the kickoff of the revolution, and then they also mentioned that 2G was the realm of web applications, which I would also agree with. And someone also mentioned like Amazon planning a phone or cell phone network. And we will actually get to the actual Amazon offering in a sec. Hopefully, I will progress past the slide very shortly.
Sure. We
do work with telecommunication partners quite closely for other reasons, but we have a I think it's called Private 5G is the name of the actual service, right?
Well, are referring to the AWS services?
Yeah, I think that's the only 5G service we have. I'm not. It's not
my
area. It's not my area of expertise.
Sure. Well, there is a private 5G offering. Might not be able to dive into the details, but certainly we should be able to cover at a high level how the AWS they support the innovation and empower the 5G technologies. Maybe we can just move on to the next slide. I'll just, before moving on to the next slide, briefly touch on the 5G part, right? There's interconnecting the people, that aspect we have already covered, but the ultra fast, that is what I would like to highlight here. The ultra low frequency, higher bandwidth, that is a key differentiator, right? So with 5G. So it is scaling faster than any previous mobile generations, but I'll talk about the trends as well, meaning what, in terms of the customer consumption, in terms of the adoption of 5G and various technologies of 5G as well. So first of all, if our audience were wondering why did we decide, industry needed 5G, right? So this is starts from GSMA intelligence. The mobile data usage in GB per user per month, if you look at it for 2020, I'm just highlighting the average across the world is 9.4 GB per user per month. And the forecast or anticipation for 2026 is 34 GB per user per month. and we are halfway through now, 2022. Maybe I'll show some of the numbers as well, but it's basically on an average 3.6 times the increase in the mobile data usage, right, per user. So I think that's quite significant. But if you look at these numbers, right, it is scaling faster than any previous mobile generations, and we expect 5G subscriptions to reach 1 billion by the end of 2022. All right.
I'm probably the odd
Well,
one in the room. Like, I
yeah.
actually kind of hate 5G. It's really finicky in New Zealand. I much rather the 4G network. I try to actually tell my phone not to connect to the 5G network, but that's like any new technology. There's always going to be teething issues, right?
Mhm.
Especially with coverage.
Yeah. So the 4G is mature, obviously.
Mm.
As you know. The 5G is evolving, but it is evolving faster. So it is growing. The penetration of 5G, particularly, is growing 3 times faster than 4G era. Right? And as you have rightly pointed, there are still areas, there are still gaps, there are still that needs to be addressed, but it's growing. Well, that's
Mm.
what I can highlight here. So, as you've pointed earlier, early on, sunsetting of 3G networks as a way to release valuable 5G spectrum as well. Right? So it is in the planning, right?
Yep.
So, and the other numbers I can show is the monthly average usage per smartphone is expected to pass 15 GB in 2022. So if you go back to the previous one, for example, so it's 9.4 to 34. So we're pretty much halfway through, and it's already expected to 15 gigs. So it's on track as per the forecast is concerned. Right? So I just want to show some numbers as well on how how the adoption is happening. So this is from the open source, Open Signal. This report was generated recently, actually, in June 2022, this year. So this is mainly some benchmarking is happening here, right? So what I wanted to demonstrate here is, or to show our audience, is that the Korea is continuing to top the global leaderboard with the highest average of 5G download speeds, 432.7 Mbps. That's the download speed, right?
It's really hard to beat Korea, though. Korea's like, in terms of networks, is insane. Like, I don't think we'd ever be able to beat them.
Yeah, absolutely. If you look at the subscriptions, right? For instance, South Korea has nearly 13 million 5G subscribers after a net addition of almost 1 million subscribers in the first month of this year, right? So in the first months of this year, not first month. So that's the kind of the adoption rates in South Korea. So that's pretty much leading the board here. The reason I've included New Zealand here is New Zealand is it maintains its top 15 rank, but Australia drops off the table. So,
Australia's never done internet particularly well, though.
Yeah, that's right.
Although someone was actually mentioning they got 700 megabits per second on Verizon and NJ, which would be okay, my states knowledge is falling off the I should know this. Oh my god, I have so many American friends and they're gonna hassle me relentlessly for this. New Jersey, there we go. I knew it. I feel so dumb right now.
It happens. It happens. Sometimes it's not easy to recall some of the names. Actually, I lived in New Jersey many years ago. So, yeah. So, yeah, in terms of the adoption, as you pointed, the Australia would not be, right way up there. It's dropping off the table. And Singapore has become global top 15 market for 5G download speed, despite new spectrum scarcity there, that country, right? That's why I've just highlighted here. And then Philippines is another market, right? That's ramping up so rapidly. So in Uplift for video experience, Philippines sees the highest improvement with a 79% increase in mobile streaming, mobile video streaming experience with 5G compared to 4G, right?
Yep.
Yeah. So I'll show you some of the numbers as well, just at a high level, right? This is mainly to see the standalone 5G adoption in numbers. So if you look at these numbers, they look quite interesting. Is it called aqua color or green color? My wife tells me that I'm colorblind, so I don't know whether that's true.
I can't help you either. I'm also red-green colorblind. I can't tell a blue
Right.
from a purple. It's quite embarrassing. I have to stare at it for ages, and then I have a 50-50 guess.
I'll go with aqua. Yeah. So this aqua color, right? It indicates the standalone 5G numbers currently live, and the orange one indicates the planned one. So if you see the live ones, the APAC region, that leads the way with Europe planning to ramp up over the next few years, right? Like, for example, as I've just mentioned, South Korea currently has nearly 13 million 5G subscribers after a net addition of almost 1 million subscribers in the first months of this year. So new use cases are rapidly emerging in these areas.
As our audience also pointed out, the density of population within those Asian countries, especially like Korea and Japan, like it really lends themselves to the implementation of these mobile technologies. Like that's a really good call out, because that's why we quite often see those as the test beds for these technologies, because they do have that scale right there.
I couldn't agree more on that.
But it's quite interesting to see that APAC is in there as leading the way.
Yeah, absolutely. The density it certainly plays a significant role here, right? So even in India and China and Philippines and South Korea, right? If you look at the subscription numbers, there are millions you're referring to, and also new use cases are rapidly emerging. So that's another key observation. And I would also like to mention that Nokia, they deploy first 5G standalone RAN, that is a radio access network, sharing network for M1 and StarHub, that is in Singapore, joint venture, right? So the commercial deployment of 5G standalone network will introduce compelling new use cases for in this APAC region, and of course everywhere, but especially APAC region, as they are actively pursuing such new use cases, right? And they cater for the growing demand for data in these countries, especially, for example, in this case, you look at Singapore at the forefront of 5G standalone technology in the region, right? And Nokia is already, driving their first standalone in that region. So on that note, again, these are the same numbers that I just wanted to show in terms of the standalone, the 5G numbers. The 5G, this shows the comparison between 5G and standalone 5G numbers. The aqua or green color, what do we call it? These are standalone 5G live, and this is standalone 5G. The red one is standalone 5G in planning, and the black color here is 5G that are live, right? So yeah, Asia Pacific or APAC, you can see that it's leading.
Yeah, we all love the good graph.
Yeah, graphs are good, man. One picture that shows more than 1,000 words. So, so maybe just briefly talk about the technology overview as well, Casey, if you reckon. Yeah.
Yep. Well, let's power through it.
All right. Okay. as our audience already know, and we are aware of, more and more customers need to collect and analyze and transfer massive amounts of data within their operations, because the data is becoming as an asset. The data, the volumes are significantly increasing, right? For operations point of view, for the end customer consumption point of view. So and also from the large number of connected sensors and edge devices prevalent in today's enterprises, it's unarguable, right? So video content is rapidly increasing as well. New applications that require ultra low latency connectivity to end user devices are increasing, and thousands of smart IoT devices, that place new demands on corporate networks nowadays. Right? So there are many benefits that 5G brings, right? So the notable benefits are, ultra. We'll talk about the notable benefits in terms of, how what the 5G brings into it. But I'd also like to talk about the deployment model, right? The private 5G and public 5G. So in terms of the in terms of the private 5G, right? It's deployed within on-premises locations. For example, you talk about university campuses, or talk about the stadiums, sports arenas, right? Or even manufacturing units, right? So they usually they augment existing wired or Wi-Fi networks, right? They provide the high reliability, security, and the latency, and specific bandwidth is allocated to it. And yeah, so that's one type of deployment. Another type of deployment is public 5G. This is deployed by the CSPs or DSPs. CSPs meaning the communication service providers and mobile network operators, right? And it spans geographic areas. So the key difference is in private 5G, the geographic areas are limited or restricted, but 5G, it's broader than that, right? So from your point of view, Casey, in terms of the Wi-Fi networks and private 5G, I could recall some conversation that we had on this as
Yes.
well, right? Some sort of comparison, and whether there's a replacement or it's a complement. I would be very keen to hear your comments on that as well.
Yeah, so how I've come to reconcile it with my brain is the fact that if you were doing anything in the private area, such as like if you're going to be monitoring like or adding devices within your factories, anything like that, using the Wi-Fi backbone would make a lot more sense because you probably already have the infrastructure in place. But if you're doing an event as ad hoc in a location that you don't really have much infrastructure in place, then the private 5G, and as your earlier use case around a stadium, where having a private 5G would make sense, because a lot of the time you won't have the cell structure in place to be able to service 20 or 100,000, depending on what country you're in and how big the stadium is, like that amount of people. And you don't really want to be putting in place the Wi-Fi router infrastructure to actually even enable having that many people connect to your Wi-Fi, and all of the difficulties that presents. And if at the end of the day everyone's going to have a cell phone that can all connect to the 5G, and then having that act as an endpoint, it makes much more sense in that way. And that's where it's talking about, it's going to augment your existing Wi-Fi solution, because at the end of the day it's probably going to go into a Wi-Fi backbone. So I think in terms of just making sure that you sanity check the use case and whether or not the 5G route or the Wi-Fi route or some other wireless technology would make sense for that particular use case. Because yeah, the one where it says the Industry 4.0, I'm not entirely sold on that as a 5G use case. But then again, as I mentioned, I'm not an expert on this, so I'm still just trying to reconcile with my own experiences and how do I say experiences and my understanding of it.
Yeah. I couldn't agree more on the difference between the 5G and Wi-Fi that you talked about. The way I see it is also that there are two different technologies with the different strengths and weaknesses, and then identifying the right use case. I think that's the key, isn't it?
Yeah.
But again, if you look at the differences, right, like throughput, latency, security, architecture, and coverage, those are the key criteria we could use to do a comparison. Obviously, we wouldn't be going into the details, but just touching on it at a high level. For example, if you look at enterprise Wi-Fi, it is simple and cost-effective to deploy and enjoys wide adoption, but suffers from coverage, the capacity, reliability, security, and handoff issues. Right. On the other hand, if you look at private 5G, it helps address these limitations. It offers greater performance, better control, reliability, and density. The better density than Wi-Fi, making it more appealing for demanding workloads.
So definitely better density
Yeah.
than Wi-Fi. Like Wi-Fi router endpoints are notoriously hard to get right. Even
Sure.
like a seasoned infrastructure IT specialist and stuff like that. Like I've been to many businesses or like sites where we've tried to run like immersion days or like other training, and then the internet over the Wi-Fi had just really let's just say prolonged the experience into a semi-torturous experience. So yeah, and then a lot of the time I've just been like, damn this, I'm just going to launch a 5G Wi-Fi hotspot, and that for the most part solved a lot of the issues.
Yeah, absolutely right. The coverage is key. The density is key. If you look at the transmit power allowed for Wi-Fi access points is low, right? And it limits access points coverage area. And you can get much better range with private 5G because the licensed 5G spectrum has a higher transmission power, right? For example, you may be able to deploy a single 5G transmitter instead of a dozen or more Wi-Fi access points. And well, the elephant in the room is cost, but it may be very contextual. So, for example, in this case that I've just described, cost of the 5G may be better cost-effective option, right? So, anyway, moving on, I'd like to briefly touch on, well, I think this we have already covered, briefly touch on the major enhancements with 5G, right? The 5G being designed with flexibility and scalability in mind in order to provide this unifying connectivity platform, as we looked at earlier, Casey, for future innovations, right? So the mobile industry has broadly agreed on the and defining three main categories of 5G services here, right? The enhanced mobile broadband, that is a EMBB. It's the technical term that we use, and URLs. You see, that is I'll just call it massive Internet of Things, right? And the mission critical control is another key criteria, right? So each driving a very diverse set of requirements. Yeah, sorry, you go.
I was also going to say TA over J seems like he's a bit of an expert, or he or her, I should say, is a bit of an expert in this area. So if you want to actually add any of your insights, then feel free to type them out, and we will flash them up on the screen as well, because I definitely want to make sure that we share the knowledge as well. And I'm well aware of the fact that we're not the only ones that are experts. Well, I'm not an expert at all, but so if you're an expert and you want to share your opinion, then go for gold, and also share your expertise. And yeah, definitely just type it in, and we'll just promote it up on the screen.
Absolutely, that would be much appreciated. Again, on that note, I'm not an expert either, but there's so much, at stake. So yeah, it's always good to hear and learn new things. Well, in terms of these key characteristics, right? If you look at it, the speed point of view, it supports 100 Mbps average user data per peak, and the data rates of 100 Gbps. well, that's a significant achievement, right? And the latency point of view, as we looked at, it's an ultra reliable the low latency. Well, that's the key, enabling the massive IoT adoption and the growth rate in the market currently, right? And for the mission critical applications, maybe I would I would mention about the manufacturing industry and the medical industry, the surgical industry. We're not there yet in terms of adopting for surgical. I'm not discounting that there are there are any technologies currently being used, the 5G currently being used for surgical, but if not, we're not there yet in my view, and based on my study, right, on this subject. But yeah, we're pretty much in the making. All right. So that's. Is there anything else you want to touch on this, Casey?
I'm all good.
Good. I'm only conscious of time and wanted to cover some of the areas in terms of how AWS plays a part in this, right? The innovating on AWS in a 5G world. So there are a few areas I just want to touch on, right? The 4 key areas of potential benefits of cloud native 5G network builds, right? If you look at the first one, the networks cloudified, it's about moving networks to the cloud to orchestrate secure, scalable, software-driven network, right? So that's the key I want to highlight here, the software-driven aspect of the network. And then by moving to the cloud, and AWS supports simplification of the operations in terms of the OSS, in terms of the BSS operations, right? And then from the customer experience point of view, sorry, apologies again.
Have to do your interpretive dance.
Yeah, I need to do something about it. Casey, I need to hire a dancer next time. So
it's experience.
It is, man. It is, yeah. So this is an enhanced experience to this session. So my brief dancing sessions here, right?
Yeah, you don't normally dance with customers, so they should be privileged.
That's right, exactly. So yeah, I think that's a nice segue into the next topic. There's a reimagined customer experience to anticipate usage patterns here, right? The changes with artificial intelligence, and AWS offers a variety of ML services, discovering new use cases here, and offering with the data to deliver excellence of services, and then unlocking growth to accelerate innovation. That is mainly to where we offer various services to monetize the 5G. But again, I'm not referring to a service in the marketplace or so forth. Well, we do have various partners, right, offering services in our marketplace, but this is more of a leveraging AWS services or AWS offerings to suit the enterprise's specific needs and their customers' needs, right? And then customers can start small and scale on demand, pay as they go, and monitor and manage their networks from the AWS console and so forth. So this is quite broad topic. Just touching just at a high level on that.
Also, one thing to note is that this here is, it can actually be generalized to pretty much any single business or industry, like any of these touch points, because really they are quite broad. And at the same time, when we're dealing with telecoms, because they generally have some type of legislative need to have infrastructure either like on-prem or in-country, then we quite often will see a lot of hybrid type solutions.
Absolutely, yes, you are spot on that. Some of these are pretty much across the industry, but we have 5G specific offering and implementations as well. If you look at the Dish Networks in the US, we have enabled the standalone 5G. Right? And also in other regions as well, even in Australia and New Zealand region, right? We are working with some large telcos to build proof of concepts on 5G. That is basically leveraging the custom implementations for them. For example, test automation, network automation, zero-touch multi-access network implementations. Those are 5G specific implementations, even though the concepts can be leveraged across the industry, but these implementations working with the likes of, working with some partners and mobile technology vendors, and they deploying on our infrastructure. Yeah. So, yeah. Unless you have anything else to add to that, I'll move on to some use cases in the interest of
Let's
time.
jump into use cases.
Yeah, sure. Jump into the use cases just to touch on the 5G, the 5G mobile network. As I mentioned, it's an evolutionary path, right? And not a point solution. Right? So that includes standardizing specifications, a range of implementation choices, and a long list of aspirational goals, right? So in terms of the use cases, if I look at it here at a high level, I've got the media and entertainment workload applications here, that is delivering high resolution live video streaming, high fidelity audio. And then if VR and autonomous vehicles, there's a lot of use cases in terms of the immersive technology, AR, VR, and MR. 5G and immersive technology, they are fundamentally changing the way we live, we work, and we consume information and media. The physical and digital worlds are now bridged, I can say, starting with augmented and virtual reality, right? So the immersive technologies are becoming more intuitive and natural. And I myself had some experience actually recently. So moving from being a screen-based to voice or gesture-based, interactive content has the power to transform enterprises and deliver consumer experiences that will define the media and gaming industry, right? So the 5G plays a key part, obviously, in terms of the data rates and ultra low frequency, right? Ultra low latency. There's another thing. Well, again, you got IoT devices and industrial automation, as we briefly touched on earlier, Casey. The private 5G could play a significant part in the industrial automation sector as well. There are two more, which is not here, but I'll just mention, just as a food for thought, cloud gaming. That's always fascinates me. Yeah, but I've not seen a real world example, but our audience may have seen that in real world examples of cloud gaming. But personally, I haven't seen yet. But that's something that I'm very, very keen, and to explore the opportunities in that space.
Yeah, the evolution in the gaming side is another whole topic that we should really cover at some point on the channel. I am trying to track down a couple of our game specialists. Both have actually worked on some big AAA games industries, so it's quite, that hopefully will be a topic that we do next year. And if you have any topics that you want to know about and you're watching this, then definitely chuck them in chat, and then I'll add them to our list of content that I need to track down specialists for.
Oh, excellent. That sounds excellent. Thanks, Casey. So yeah, in terms of 5 use cases, maybe I'll skip this one. This is a slightly, diving a little bit deeper into some of those use cases we talked about earlier. But let's talk about the real world deployments, right? For example, if you look at this TinyMind, right? This is mainly, to deliver a solution to deliver packages, right? I'll explain the way it works. This is basically a company based off North Carolina, right? So a customer submits a request for delivery, and a package. They review the package guidelines, they enter sender and recipient information, and they confirm that the company can serve the delivery request. And then they put the package in the robot, and when the robot arrives, the sender will use the provided app to open its lid, place their package in the compartment, and send the robot on its way. So to follow the robot's journey, and both sender and the recipients, they can use the app to track the robot's progress through the town, and recipient collects the package from the robot. When the robot arrives, the recipients will use the provided app to open the lid, collect their package and compartment, and send it to the robots on its way. That is the use case. But what are the key challenges here, right? The key challenges here is to avoid collisions, right? And any delays, right, that put robots and pedestrians at risk. So here the ultra low latency plays a key part here. Yeah, right. So in terms of how the AWS solutions help here, you've got an AWS Wavelength solution that offers real-time video analytics to detect obstacles and to mitigate those risks, right? So what was the business outcome? 30% reduction in video feed latency, so that these robots can stop faster than they could have before, right? So this is a real world scenario. Yeah.
Yep.
And then another one is our own Amazon Prime Air. So it's basically drone delivery. They've trialed it in California, USA. So the challenges here is mainly how you get items to customers quickly, cost effectively, and most importantly safely in less than an hour, right? So that was a objective, and I can say challenge as well. So what we did was we have created a sophisticated and industry-leading sense and avoid system that will enable operations without visual observers, and allow our drone to operate at greater distances, right, while safely and reliably avoiding other aircrafts, people, pedestrians, pets, or any such obstacles, right?
So and also, one of the other key things, because it is a aerial drone, what a lot of people may not know about, but you also have the no-fly zones around any airport. So when you have big cities that have big airports and multiple airports, then the ability to do like air delivery significantly decreases. I think Austin, Texas is one of those.
Sure. Yeah, absolutely. Yeah. Yeah, Texas is I think they've already in flights many of those implementations. And
yep, it's just a legal one, because drones can't enter those no-fly zones, obviously, at any level without getting clearance from the traffic control, especially if they controlled airspace. The whole legal thing around airspace is really, really interesting. I won't go into it because it's not the purpose of the channel. But if you are looking for it, there's some really, really interesting channels around the difficulties of air delivery and legal considerations.
Sure. Yeah, absolutely. But I would expect in the years to come, some of these challenges can be mitigated. I've got one more, but in the interest of time, maybe I would stop here. I wanted to talk about the crowd management. It's also a very interesting use case, real world use case. But maybe I would stop here, and maybe we can wrap up this conversation.
Yep. So while we are wrapping up, because we are coming to the time as well, if you have any questions, now is the time to ask them. We'll, but otherwise we will call it there. It's been while we wait for people who furiously type in the keyboards, or maybe not, just stare at us blankly. Either one is fine. I do want to thank you for your time, Sam. I know it does take a bit of effort to put together these presentations and do the research around them. So thank you very much for taking some time out of your day to come onto the show.
It's an absolute pleasure and honor to be on this show, Casey. Again, it's always great to share what I've learned and from my experiences. I've not been an expert in this, but it's always great to share.
And it's been great to deepen my understanding of the 5G and the mobile technologies. It's definitely something that That's also one of the reasons I quite like hosting the show, because I get to learn random stuff, every week on the hour. I believe, just for everyone watching, next week is going to be our last broadcast of the year, and then we'll be going on break. We was supposed to start on February, but due to popular demand internally, we will be presenting starting, I think, the second or third week of Jan. So if you're around, and at the same time every week from then on out, we'll be doing it weekly next year as well. I'm bringing on partners, other solution architects, hopefully ProServe. I'll get some service team members and of the wider, AWS team involved. So yeah, so next week is definitely going to be the last one. Then we'll see you back in late Jan. And to Van, I hope everyone has a great Christmas. Same to you, same as well, because I probably won't see you into next year. So everyone have a good festive period as well.
Thank you, Cassie. Same to you. Have a great Christmas, and to our audience as well. Have a wonderful, wonderful Christmas season, and Happy New Year as well.
Yep. Enjoy your Christmas and have a good New Year. See you, everyone. Masawa.
See you.